Let's do an introduction to factoring x squared plus bx plus c. So to get where I need to get, first thing I want to do is I want to multiply x plus 3 times x plus 5. So we're going to distribute here. So we're going to take x times x, which is x squared, x times 5, which is 5x, and then distribute the other piece there, which is a 3. 3 times x is 3x. 3 times 5 is 15. Now, when you combine like terms there, you start from the highest, go to the lowest. I have an x squared. 5x plus 3x is 8x. And then we have a plus 15. So this is multiplying, going from top towards the bottom there. That is multiplying. What we are doing is we are factoring, which is just basically like division. So we are actually working backwards. So we're going to start here, and we want to end up here with x plus 3 and x plus 5. Now, what I kind of talked about in class is kind of a relationship between this problem and this one. How do we go, and what up here is influencing my answer down here? Because if we know the secret to go from here to there quickly, then we could use that secret and that kind of tip and that pattern to work backwards. So things we talked about in class was, well, if you have the 3 and the 5 and you multiply those together, that gets the 15. But also that 3 and 5, if you add them together, gives you 8, which arrives us to this, our general rule. Now, in this video, we're only dealing with x squared plus, I'm going to use in place b and c. Now, we're eventually going to work with where there's going to be a number in front of this x squared. But for this one only, we only care about if it's just a plain old x squared. There's actually a 1 there. So we're going to have a different way of doing things if there's a number here. But here's the trick we're going to kind of use. We're looking for two numbers that multiply to c. So two numbers that multiply to the back number, but these same two numbers need to add, add to b. So two numbers that multiply to c and add to b. So we're looking for two numbers that multiply to the back, but those same two numbers need to add up to be the middle. So I'm going to show you a few examples of how that works. Now, the best thing about this is we're going to be able to check our work and know we're right. So we're going to factor and check our work. So I need two numbers that multiply to 12, but when we add them together, we get 7. So what I like to do is I first start off by listing out all the different pairs of numbers that multiply to 12. So I start small and work my way up. So 1 times what gets me 12? Well, 1 times 12 gets me 12. Then I think about 2. 2 times 6 gets me 12. 3 times 4 gets me 12, and that's it. Now what I'm looking for is I need two numbers that multiply to 12. Well, here's all the different pairs that multiply to 12. I need those two numbers to also add to 7. So 1 and 12, that's not going to add us to 7. 2 and 6, that's not going to add us to 7. Oh, here we are. 3 and 4 will get us to add to 7. So I'm going to take a little guess here, and then we're going to check and make sure our work is right. Now notice how we started. We're starting here. We want to end up with two parentheses. And what we're going to have is we're going to have an x in each parentheses. Now we just need to plug in those numbers. And now we're going to use 3 and 4 because positive 3 times positive 4 is 12. Positive 3 plus 4 is 7. So we're going to put a plus 3 here, a plus 4 there. Now I'm not going to circle this and say it's my final answer yet. I want to check my work to see if I'm right. So we think we went from here backwards to the parentheses. So how do we check our work? Well, you just multiply. So we're going to multiply and see if we get this answer. So I'm going to multiply this out and see if I get my right answer. So x plus 3 times x plus 4. We should be comfortable with multiplication now, so I'm going to do this a little bit quick. X times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. So when you combine like terms, we get x squared plus 7x plus 12. Well, if you notice, this is the same, exact same, signs and everything as my original problem. So I know that x plus 3 and x plus 4 is my answer, so I'm going to box that up. So let's do one more example. X squared plus 11x plus 28. Again, need two numbers that multiply to the back. Those same two numbers need to add to the middle. So I'm going to list out all the different pairs of numbers that can multiply to 28. So I start small and figure out 1 times what, then 2 times what, 3 times what, 4 times what, so on and so forth. So 1 times 28 is 28. 2 times 14. Let's think. 3 times anything? No. 4 times 7 will get us 28. 5, not going to work. 6, not going to work. So there's all my pairs. So I want to see which of these pairs is going to add to 11. So 1 and 28, that'll give me 29. No. 2 and 14 gives me 16. No. Oh, 4 and 7, that adds to 11. So we think it's 4 and 7. Again, I don't want to move on until I know for sure. So I have my two x's. Another thing here is the order doesn't matter. If you put a 4 here and a 7 there, that's the same thing as putting a 7 and a 4. So if you want to put a 4, 7 there and check it, I'll show you that we get the exact same thing. And the reasoning behind that is think about basic multiplication. If I said, hey, what's 2 times 6? That's 12, right? Let's change the order. Well, what's 6 times 2? So I just flip-flopped them. 6 times 2 is 12. So down here, if you flip-flop the 4 and the 7, it's not going to make a difference. So I have x plus 7 times x plus 4. So really quickly, we get x squared. X times 4 is 4x. 7x, 28. And when you combine like terms there, we get x squared plus 11x plus 28, which this is the same as my original. That way I know x plus 7 and x plus 4 are my correct answers. And that is it. So that was a little bit of intro to factoring with x squared plus bx plus c. I'll have plenty of videos to follow up this one as well to help us more with factoring.